All right, so there's a couple of people who are probably interested in this, so I'm just going to do a really quick recap on what we did last stream. So, there is actually a specific Steam and Steel commit that you can have a look at that I might put a post to later, but it's actually quite simple at this point here. It starts with a model loader, which basically you implement iCustom model loader, and then you come up with a a way of detecting when your models should be triggered. So in my case, in my block states for the dummy Steam transport, I have a model of Steam and Steel Steam transport debug, which when it actually comes in as a resource location also has model/block in front of it. So I'm looking for where the resource domain is Steam and Steel and the resource path is models, block, Steam and Steel, Steam transport debug. These are awful names, we'll fix those. Matchy. There we go. Now, this has the resource manager reload event for whenever someone like presses F3T or F3A, I think it is. So whenever whenever the resources get reloaded, like a texture pack coming in or something along those lines, this will get triggered. This is your opportunity to register any kind of textures or whatever that you need. I'm using vertex coloring, so that's not actually an issue for me. So in that, you return a model. So here's your iModel here. So because mine is really simple, I don't have any textures. Normally you would pass in textures that you've registered from here or something. And then you have the default state of the model, which this is all about like animating a hierarchy. So this is basically like the state of your default model, what it looks like when no animation or anything is being applied. And then finally you have your bake method, which takes in a state, and this is the vertex format for the chunk. And then you've got a method here by which you can I think this is used for remapping textures or something. Or is it resolving textures from a location? But I'm not using that. I do, however, care about the state, and I care about the vertex format. So from there, you build a instance of your model, which is a point, which is an animation at a point. So not necessarily an animation, but it is a model at a certain point. So in this case, we have a state, we have the format. Now I've implemented iFlexible baked model and ISmartBlockModel. The flexible baked model is what I call the model instance. I found that the naming of this is a little bit confusing. And the smart block model, let's hide all of this for a sec. So this gives you your ability to handle a block state and return a new model model instance. So basically this is your point of time as things change. Now in terms of implementing the iFlexible baked model, so this thing has a thing for getting the vertex format, and it implements iBaked model, which gives you face quads, which is useful for cubes, your general quads, which are used for like non-cuboid shapes, Ambient occlusion is your smooth shading. Some things render in 3D in the GUI, some things do not. In our case, we almost always return false for the built-in renderer. Your particle texture is whatever kind of texture you're going to use when you're breaking. And this is no longer used to my knowledge, but we still have to implement it. So, with that in mind, let's take a look at the implementation of what I've got so far. Okay. So my general quads, this thing here is actually pretty simple. Basically, my particular thing is a cuboid shape, and it renders the 6 sides of a cubes, more or less. I don't particularly care about ambient occlusion, so I've got it disabled for mine. Is GUI 3D? Yeah, probably should be. Not a built-in renderer. I don't care about a particle texture, or more accurately, I haven't registered one, so that doesn't work. This is the deprecated get item camera transforms. We're just going to return default here, which is just a blank one. I think it's got identity on the things. We're just passing in whatever format we got when we built this model instance. The handle perspective stuff actually comes from this perspective aware model, which once upon a time I knew what this was about, but I can't remember. I think it's to do with texture warping when it gets too close to the camera or something. And the handle block state we haven't actually implemented yet. So the really interesting bits are get face quads, which basically, for a given side, we're going to return a list of quads. So basically a set of 2 triangles. Now, as it turns out, if you need to return just a single triangle, what you can actually do is repeat, rather than having your 4th vertex in a thing, you basically repeat it in one spot. And what that does is that creates a triangle with absolutely no area. And I'm led to believe that OpenGL is smart enough to actually just discard that triangle altogether. Doesn't render it at all. So that's how you achieve a triangle from this baked quad. Otherwise, you'll want to make sure that that you've managed to decompose your thought processes into triangles. So if you've got a 3D program, you're outputting baked quads, you would make sure that your models are triangulated, or quads, or whatever it is you need to do. So forget about this stuff for a sec. This is specifically to do with my model. And instead, you can see I'm switching on the sides. Hey Alf, how you doing, buddy? I'm switching on the side, and each of my sides has 2 quads associated with it, one of which is my water and one of which is my steam, because that's what I want to visualize. And at the end of the day, it's basically creating a unpacked baked quad builder. I'm using colored quads, so I've set this property. And this basically adds my quad builder to my immutable list builder. And then I've got my 4 vertices in here. Oh, dude, that's not cool. Yeah, I know the feeling. Although I'm guilty of sometimes wishing that I could go home spewing, because I'd rather be doing this than my work at the moment. Anyway, so this is one quad here. So 4 vertices making up 1 square, or a quad. But the way that you build the vertex data is kind of important. So we've stolen this from Fry. Fry had this code in his B3D stuff, and it's actually quite useful. Because what happens is you end up with this, the format that we got passed in basically has elements associated with it. So it might have a position, it might have UV texture coordinates, it might have colors, it might have a normal map, a normal vector, and I forget there might be some other things. What do we got here? Yep. So what this method allows us to do is basically iterate over the elements in the format in the order that they're expected. Because fundamentally, when you pass data to your graphics card, this thing is going to say the first bit is going to be the X coordinate, the second bit is the Y coordinate, the third bit is the Z coordinate. Then we're going to do the colors, red, green, blue, and it's going to expect every vertex to be in a very specific order. So this method here allows us to abstract away from whatever the vertex format is and just sort of say, here's a whole heap of data, just fill it with whatever you're expecting. So if you're in the position, then we're going to put these vertex positions in here. This thing takes a W, which is, in my case, always 1. When it's in the color, we go looking, we calculate the diffuse light from the face normal, which I think oops, hello. I should probably be using this in my case. Yep. So this manipulates your color. Your UVs are your texture coordinates, which basically you pass in your texture coordinates, which in Minecraft should be from 0 to 1. If you go outside of those bounds, you run the risk of having, like, Minecraft will put all of your textures together on a single sheet, and then you get texture atlas sprites, which represent a single small part of the texture, which makes up your texture. And it gives it to you in the perspective of 0 to 1 is your little texture. So if you go outside of those bounds and you say 2, then you'll end up with a bit of your texture and a little bit of somebody else's. So in normal OpenGL, where you don't have this kind of texture stitching, it's possible to have repeated textures and you can get it to just loop. But in Minecraft, not a good idea. So if you absolutely need to do that in Minecraft, you should be looking at probably having like multiple quads, unfortunately. But yeah, so this is where we basically take your texture coordinates that you've passed in and we get the actual position from the sprite. And if we haven't specified a texture, then we get this. Or do we? I wonder. That might be why I'm getting yellow. Vertex normals. So vertex normals affect the lighting on your model. It's basically the way that your, like if you've got a face like that, your normal is normally like this. That is not always the case though. So we have the option of either a per vertex normal or a face normal. I could simplify this in my code, but that's not actually necessary. Alrighty, so that is packing vertex data. So we pack the vertex data, then we build the unpacked baked quad, add it to our immutable list, and at the very end we build it. Now, it is not safe to return a null list from this method. You should, if you have no intention of rendering a side, you should return collections.emptylist. And the same thing goes for the general quads. It's not safe to return that there. To return a null from there either. You will break Minecraft. So that is a 15-minute rundown on how to create custom polygons in the thing. That right there is your ISBRH replacement that everyone's been complaining about. Like I have effectively written my own static block handler. Now, let's get on to some interesting stuff here. This is... Let's get rid of this for a sec. Alright, so let's try running this for a moment. And what we'll do is just have a look and observe what kind of thing do we get into handle block state. And I'm also going to have a look and see if my system is actually hitting this in here, which would explain my yellow steam. That's my block state, and yes, that is really annoying. Why? No, hang on. That is exactly what It just occurred to me that have a look at the builder. Set quad colored. Set quad orientation. Yeah, maybe I should be doing that too. Oh, well, it's not too bad. Quad builder.set quad orientation to side. Just paste that a half dozen times throughout this code. Okay. 3T to reload the texture, the resources. Yep, that's fine. So, oh hello, now we've got some shading on here. That's kind of cool. I like that. G'day Fry, how you doing, buddy? Now then, let's add some state to this. Now it's probably related to the fact that I'm rendering the entire thing on the translucent layer, which means that the Z buffer is disabled. Okay. Yeah, no, I'm blaming this on myself. Um, well, shouldn't it be? Like when you're rendering transparent stuff, like you should be uh, how do I mean? Like the Z test is completely different on the translucent layer. Faces. Who's doing the depth sorting? Is that inside of Minecraft? Because I'm not. Okay. If Minecraft's doing it, then that would be good. Um, I mean, I would actually like my object to be properly translucent. Oh, let me think. Let me think. Okay, that's cool. So, putting all of that aside, resource. No, where are we? Debug. Here we go. Create block state. I need some states on here. Nope, hang on. I wanted these to be unlisted properties. I think. Uh, yeah, I think I need it to be property boolean integer. Yeah, that's what I thought. Yep. Because this is going to be floating point data. And seriously, screw trying to do block states for every single discrete floating point value. So is that your answer to why the why everyone's having weird issues with translucency? Oh, good luck with that. So, for the benefit of anyone who's watching the stream after the recording, Fry and I have just been discussing um, why my model was rendering stupidly. The short answer is the Z buffer, which um, I just assumed was turned off, and Fry didn't think that it was, but turns out it is. So he's going to try enabling it and see what happens. Um, you might need to play with the Z test. Oh, let me think. Um, where am I going to put this? put it in the client. No, I couldn't. Because hey, Fry, when would you ever need an unlisted property on the server? Can I take a potshot guess and say never? I mean, the... Hmm. Hmm. Um, well, I mean, I think it's entirely plausible to use an extended block state for this. I kind of like the fact that the extended block state can make a block appear to be much more complicated than it actually is. Yeah, so block state isn't a thing limited to rendering, but an unlisted property, um, like, that's nothing that you can, um, like, you can't really, um, hmm. Anyway, it's an interesting discussion, that's for sure. And where the hell did I put my... add my animation property in there. So let's stick it over here. Float unlisted property. Implements unlisted property of float. Constructor. See if I remember how to do this. It's been a while. So we're going to go string name. Return. Good one. Name. Value to string. Yep. And the get type thing. I've forgotten what that is. Is just the type of that. So that should be a float.class. Because damn generic erasure. I could go float min, float max in here. Like that would make for a valid float unlisted property, but I'm not going to. Because it seriously doesn't matter that badly on this. So this is going to be the... Is it? totally is. I like it. I like not having to write my own code. So this is going to be steam density property. There's new property float. And I like the fact that it has a validator on it too. That's pretty good. Oops, what have I done wrong here? Oh, of course. Condensation property. Okie dokie. Oh, now I have to remember how this works. We've got an extended block state. View. This. Property 0. Steam density. Oops. Condensation. All right, cool. That will be fine. Not doing any of that. Right, cool. So I should now be able to just get that information out. Maybe what we'll do is borrow this here. When I was using a counter, I should take that out. world.setBlockState pos state.withProperty. Let's do condensation. Value. Convert. Really? T extends comparable of T. It's not within its bound. I guess, is float not comparable? Totally is. Oh, of course. I think. I'm just going to cheat for now. Sorry, Fro. I should be doing like safe casting and all that crap, but there we go. Model instance, and so we should find this state here should actually be a bit more useful now. So I'll just verify that before I start messing with it. Okay. So that was a thing, was it? Alrighty, so what kind of state do we have here? This should be a pretty simple thing. Yep. Optional.absent. I'm fine with that. That was a little unexpected. Was that a null pointer or an invalid cast? Null pointer. What? What the hell part of that was null? Oh, right. Yeah, that's the thing. Yep. Fair enough. Uh, Red block state. Set default state. Get oh, how did I do it with a fan? Get block state. Get base state. Oh, hang on. I have to do this all over again, huh? steam density property of a density of 0.5, I guess, and a condensation property of 0. Is my format code not working? Okey. Oops, we did crash. Bugger. Another null pointer. What? Hmm. I wonder if it's got to do with the fact that my unlisted properties keep coming back as optional absent. What's the deal? State 1. Unlisted properties. Or null. Interesting. It's very suspicious. Wait, why is base state null? Wait, what? Block null. Oh, because I'm in the bloody constructor. I can't use extended block state here like this. Don't think. Did I do it here? Create block state. How the fuck did that work? You can't use this before the bloody... Score, Fry? I like the sound of that. Maybe what my issue is that I should just let this be null by default. It's just... Well, maybe just try a few things, see if you can still see water through nether portals and stuff like that. Or whatever it was that they did. I extended block state. So it's just going to completely negate what's going on down here, but oops, oh dear, okay. The hell did I fuck up then? Stream died. Really? Weird. Yeah, I wonder why that died. There's a glitch in the matrix. Let's try... Do. Nope, still dead. Strange. All I did was mess with the actual state. What? Why did you suddenly stop rendering when I set some unlisted properties? Huh. Oh, g'day Raider, how you doing, buddy? Not quite sure what to make of that. Oh, is that what get extended state is for? Right. You know what would be kind of handy right here, Fry? Usages of Publix, Minecraft Forge client, get render layer. I was just kind of thinking it would be kind of useful to actually know in when you're handling the block state which layer. Well, actually, it's not even here that it actually matters. It's in this stuff where you kind of want to know. I don't know whether you'd want to do that in the state or not. I mean, I guess it's sitting right here. Right. Well, that makes sense. All right. Well, let's get back to it then. My dummy block on, get extended state. That. Yeah, that's fair enough. This block is entirely translucent, so it doesn't actually matter for this particular block. Oops, probably should have paid attention then. Do you blow up now? Yep, totally do. Still. Let's see what this is getting called. Null pointers. So Raider, I remember seeing on Twitter the other day you were lamenting the lack of ISBRH. You might want to check out when the stream ends. Check out the beginning of this because I've basically covered how to do ISBRH using this custom rendering stuff, which is basically what I'm doing. Here we go. Okay, actually has values this time. That's a start. Cool. That's actually enough. Grey Ghost is cool. I love Grey Ghost. It was Grey Ghost who made me realize that the whole petabytes of JSON thing was a load of bullshit. Return new. So this is where we're going to create a new instance of the model that is appropriate for this state. So we're going to create an overload for this. This state format. Oh, wait, what? Totally did not mean to do that. That should be this dot state. There we go. Should probably be final, but whatever. Yeah, let's leave that as final. Let's not do that. This state null format. Cool. Yeah, now that you mention it, I probably could fry. Yeah, absolutely you could, now that I think about it. Um, but I mean, half the reason why I'm going down this adventure is because people have been complaining about the whole I can't do ISBRH stuff. Well, yeah, you can. Condensation. What's your problem? Oh, this is not C sharp. You can't do that. Oh, no. Sorry, I didn't mean that as a dig at you, Raider. Because like you're hardly the first person to do this. That's kind of why, like, at the beginning of this stream, like I actually went through how to actually do all of this, simply because there is we need more information on it. But having said that, though, um, as Fry was saying, you can actually do a lot of this with actually a lot less code using the animation stuff that he's done. Like this whole thing would be completely unnecessary using the animation stuff, but bit too tired to actually go through and rework all of this to work in that framework at the moment. Steam density. Cool. Steam color is that. One day I will sit down and I will do a whole bunch of tutorials on all of this stuff. And I will see about making a schema for the JSON stuff, because we need that too. But it's all time. It's like, do I work on Steam and Steel, or do I do stuff for the betterment of the whole community? It's actually a really tough question, because I really want to get Steam and Steel out, but bugger, what are you doing wrong there? Mm. Dummy Steam transport of generic tile entity. I'll find a better name for this because I hate having to do this casting crap all the time. But there we go. And so this will be tile entity dot get. Yes, capabilities will be, I will be implementing this whole Steam system with capabilities. That is going to definitely be a thing. For the purpose of just getting this stuff up and running though, I'm just going with what I currently know. But yeah, absolutely, all the things. So, in terms of why the cast, well, I mean, you kind of have to, but like in theory, I shouldn't have to do this check because like this tile entity is associated with this block, but it's the kind of thing that I don't think it's a bad thing to check. I have seen some weird instances of like worlds getting mangled and so if you're using something like Kotlin, I read today that Kotlin will actually do this cast for you implicitly. If it notices you doing an instance of, it will allow you to use any properties off of that. But if I go generic tile entity now, it says get condensation, but that's just IntelliJ being nice. If I press tab, it'll do the cast for me. So and I need these 3 lines again. Don't need you anymore. Not that it'd hurt. See, .NET has null propagation, which is kind of awesome because it means you can basically go world.getTileEntity as dummy steam transport te dot question mark or question mark dot set condensation. So I like that. I think rather than setting the block state here, I think there's a thing I can do where I can go like um, mark block range for update. Pause. So set the condentation to tile entity.get condensation plus 100 0f. Yes, I will give you the final modifier. I hope that fires off the get extended state, but we'll find out. Well, it's not. Oops, it's not activating. What's the deal there? I kind of get the feeling that I haven't actually registered my tile entity properly. Oh, I haven't overridden create tile entity. Derp. That will do it. Really? Really? Oh, I have to override has tile entity as well. iTile entity provider. I don't remember this interface before. I like where they're going with it, but so should not do that. Instead do that. Wonder if the cupola has that problem too. Oh, okay. That interface is obviously not as new as I expected it to be. There we go. Now we're talking. Oops, did you just die? Totally did. Null pointer. What? Block container? Alright. Didn't even know that existed. I have a base class. Short answer is no. Yeah, this ain't exactly great either. Get render type of -1. That stuff's all useful. And adds in a whole bunch of stuff for supporting cactuses. There's like a whole heap. There is so much nope in that class. But a lot of this stuff is actually kind of useful. But I think what I'm going to do is implement it in here instead. So this stuff is all very appropriate. Wait, really? Why are you calling the super when the super just returns false? Yeah, whatever. We'll do this again. Let's do that. Yeah. Which to me is kind of an indication of a poorly implemented class. Like how these two things set is block container, but nothing reads it. Like obsolete behavior or something. Anyway, I don't think that actually helps with this though. Usually got to get rid of my copyright bullshit thing or actually fix it up. Oh, okay. That's cheeky. Condensate. Really? No wonder. Alrighty. Let's try and get this over and done with, because well, I was hoping to be in bed half an hour ago, but now it's 0. Not quite what I had in mind. Oh, of course. Of course, of course. That'll do. Um, No, I haven't looked at model fluid yet. I actually haven't had anything to fluids at all. Okay. Cool. Yeah, interesting. There's a whole heap of stuff in here that I'm not supporting though, like flow. There's a one thing, when I get to doing tutorials, one thing I'm going to do is a tutorial on proxying models. Um, Having like a model that's actually like made up of other models in terms of take for example like Ender.io. Like you could split up each individual little pipe that it does so that it has its own little 16 um, like 16 state thing, and then another thing that has 16 state thing, and then you might have a block that has a whole bunch of unlisted properties or something that basically makes up 16, like splits up each model into its own little tiny domain. Yeah, kind of like multi-model. Hmm. I hope your thing does actually fix that, because that's kind of annoying. So I think I can fix this if I actually change the texture to say like wool or something. But we'll fix that tomorrow. Pardon me. Um, well, yeah, your call, buddy. Um, I mean, if you break somebody else's stuff, I can't help but wonder if it'll actually be any worse than it already is. Especially since I'm not actually sure you can work around this um, in the in the context of static rendering. Anyway, so now that we've got this, yeah, it's transparent. So you've got the orange represents how dense the steam is in a pipe, and the blue represents how much water has condensed in the pipe. It doesn't really show well what it is I want to show. Kind of. I tried that originally, but not only did I end up with a lot of Z fighting, um, I also had the issue that like it was actually really hard to tell water over the steam. Whereas what I actually need to do is, now that I think about it, model instance. Height. Height. Let's try this. Oops, nope, 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 nope. Think about that a bit. Up, down, north. Yeah, that's literally what I'm looking at the moment, Fry. I think it's the steam min. I think if I change steam min to height, that should do it. Yep, cool. I'm not going to bother fixing that rendering dirt because when I go and use the actual object model I have for this, it should just work. Should just work. Anyway, let's get a pretty picture for Twitter. That's about as good as it's going to get. Nothing that I really care about. Ideally, the sides of this one here shouldn't be rendering because this block here has more water in it, but that would prevent the dark borders that we see here. But I don't care that much. It's a debug renderer. I have no intention of actually exposing this to players. Anyway, but that's a good stopping point, I think. Oh, the sorting. Sorry, I forgot to check.